Example 4.4. So here's an example, one more example for buck converter. So here we want output of 5 volt at 10 ampere from a 12 volt input. Okay, so given that the switching frequency or frequency of the switch is 40 kilohertz and we are in CCM mode. And here in the inductor current will go down to 4 ampere for the output current, and this will be I node at threshold. Okay, so we don't need any isolation, so we want inductance, the peak transistor current, and then the RMS of the capacitor current, and also the capacitance. Okay, so it also given that the peak ripple of the output voltage is 5 millivolt. So here's the blank side for example 4.4. Okay, so first of all, we will going to need the duty cycle, so we are going to start with that first. Okay, so as we already know, the duty cycle of a buck converter is given by V naught over Vs or V in. Okay, so this is 5 over 12. Okay, okay, so what we need calculate L, peak transistor current, and then the capacitor current, and also the capacitance. So as you can see from the previous example where we find the same thing as what we want to find over here. We want the L capacitance to the N capacitance to design the buck converter, and also peak transistor current, and also the capacitor current. So for that we are going to need the inductor current, and from the inductor current we can derive the IC, I node, and also the switch the transistor current. Okay, so here the transistor current over here also means the switch current or the current through the switch. Okay, because here the for this example the switch is a transistor, so instead of using switch current we use transistor current. It's the same thing. Okay, so first we are going to need the IL. Okay, so first during threshold, and later on we'll proceed with the IL for the full load. Okay, okay, so first, as we already know, the waveform for this would be starting from 0. Okay, okay, so during on we have a positive slope, during off we have a negative slope, and let's do one more, positive slope and then negative slope. Okay, on we have on, off, on, and also off. Okay, so here we also already know from the question, from the given information over here, that during threshold I naught will be I naught is 4 ampere. Okay, so this also will give us the average for the inductor current. So this is also IL. Okay, so before we go, so this is IL, so this is T. Okay, so this line over here is 4 ampere. Okay, so from here, what we can obtain from here is, okay, the ripple for the inductor current. Okay, so line is 4 ampere. So from there, okay, this line is average, meaning that is also the midpoint between this point to this 0 point. Okay, so from there we can know that this height is also 4 ampere. And if we add these two up, okay, we will have the ripple for the IL, which is 8 ampere. So here what we can obtain is that the ripple for the inductor current is equivalent to 8 ampere. Okay, so we are going to need that information later on. Okay, so from all this information, we can derive the IL waveform during the full load. IL, sorry. Okay, so IL and then this is C. Okay, so during full load, the current will not be down to or decrease until 0. So here we have the positive slope during the switch is on, and then negative slope, and then positive slope for on, and then again off we have the negative slope. Okay, so this is the waveform for IL during full load. Okay, so from the previous one, we already know this part over here, so we are going to use that here. So this height over here will be 8 ampere. Okay, so and also we also know that the average for this one is, what was it, 10 ampere. Okay, so this also means that the average of IL is also 10 ampere. Okay, so from there we can derive the peak value here, and then the minimum value over here. Okay, so here this line over here will be 10. So meaning that here, since this is 10 and the height is 8, okay, so half will be under here and the other half of the waveform is up here. So here this part will be 10 minus 8 over 2. So this is so 6. Okay, 6 ampere. And for this part, this point over here, 10 plus 8 over 2, so 14 ampere. Continuously from there, we can derive the waveform for IS, or the switch through the current. Okay, so ISW here. Okay, so we already know that for the switch current, okay, during on, as we already previously discussed, during on, ISW or IS is equivalent to IL. During off, ISW is 0. Okay, so from there we can, since we already have the waveform for IL, then we can use that for IS or switch SW. Okay, so here during on, you will follow from IL, and then during off it will be equivalent to 0. Okay, so we connect that, and then again if you have on again, then follow the positive slope of IL, and then 0 when the switch is off. Okay, and then the values for this point and this point will also follow from here, these 2 points that we already derived from IL. So this one will be 6 ampere, and here will be 14 ampere. Okay, So we can read from that ISWP is 14 ampere.